Hello, we are Design Team 2 from VTEPS, representing Motioneering. My name is Eric Alenko.
My name is Jason Lee.
My name is Wenpeng Liu.
And this is our Design Phase 1 presentation. First, a brief introduction of the topics we are covering. First, we're going to cover the various project proposals that were considered for this project. We are going to discuss the project management and timeline of this project, the customer needs, how we came up with those customer needs, and the product specifications to go along with that. Finally, we will conclude with a brief economic analysis. Just to give a little context to this project, this is an educational device meant to be both fun and entertaining, but also very effective at teaching the chosen concept. It will be focused around the BRG concept, or the Rube Goldberg machine idea. To talk about the proposal that we chose, Proposal 1 and 2 are very similar, except Proposal 2 focused on a little higher quality product than Proposal 1. However, Proposal 1 was designed to be a little cheaper. That would be its advantage in the market. Proposal 3 was very unique. As you just look at the chart and see, it was more of an incremental improvement focused on engineering rather than Newtonian physics. It was considered to be a lot harder to develop, more technically challenging though. However, we did end up choosing Proposal 3 as we valued it for its marketability and its potential profitability. This is a brief summary of our mission statement. A few things worth highlighting is that this proposal is very customizable. It won't be just one thing you can do, but rather every time you use it, it's a different experience. That will allow several products to come after it, so perhaps a chemical engineering and an electrical engineering set, allowing this product to have a longer lifespan on the market. We are shooting for at least 40% profit, as well as rolling out this line of products to allow VTEPS to be very profitable with this product in the future. Primary markets include schools and educators, along with additional sales to consumers, mostly families. Stakeholders include VTEPS primarily, but also the students and instructors that will be using this project, along with the manufacturers and the competing companies, as this has the potential to really shift up the marketplace.
And right here we have an overall timeline of a project displayed in a Gantt chart. On the left-hand side right here, these are the tasks that we want to complete over the course of the overall project. And this right here is just a visual representation of those tasks. And what you'll notice is that the critical path, which is shown in red right here, and in order to make sure that we don't go out of schedule for our project, what we can actually do is, if you see tasks 2, 3, 4, and 5 are in sequential order, so that means it'll take up a lot more time. But one way we can fix that is if we have 2, 3, 4, and 5 in a parallel or coupled manner. That way, instead of having to complete them one at a time, we can complete them all at the same time, which saves a lot of time, and it allows us more time for the more difficult tasks in the future, like prototyping, product architecture. And what you'll also notice right here is that economic analysis has been going on throughout the entire course of the project. And it's important because we need to make sure our project, even though physically it has to work, but economically it also has to be feasible.
So as for the customer needs, so we first generate a hypothetical customer profile and the use case with that, and then we use that hypothetical customer profile to find potential customers to interview so that we can get a general ideas of what the customer needs. So this is the result of our interview. We interpreted the customer statements into different criteria. So as you can see in the graph, the higher the graph is, the higher the frequency that this statement shows in our interview. So this is our QFD rating for those criteria. As you can see, the trend in this QFD rating it's not the same as the previous graph, the customer needs. So for example, customer didn't think safety as their priority for purchasing a product. But as engineers, as a development team, we consider that as a really crucial thing, because we need to take responsibility for our customers that uses our product. Other than that, you can see that customer didn't put price into their most top priority, but actually we think that in market success, price is really a crucial part, a crucial factor of that.
So in addition to the customer needs, we also have product specifications in our QFD chart. And in order to derive these product specifications, we made a competitive benchmarking table which shows the characteristics of similar products but not completely the same. Similar products of our motion hearing BRG product, which with a list of common characteristics like, for example, price, star rating, age level, etc. And from these common characteristics, that's how we develop these product specifications right here. And what you'll notice is that some product specifications, like this one right here, number of moving parts, that is almost in some way correlated with every single one of the customer needs, almost every single one. But the product specification like weight, for example, is only correlated out of these possible customer needs, and one of the correlations isn't even really that big. So that leads to our next idea of technical importance. So how important are these product specifications to the overall product? Well, based on the analysis on the QFD chart right here, since that has so many correlations with all the customer needs, since number of moving parts, we determined that that will be our number one important rating for the product specifications. And weight, which was shown right here with only 2 correlations, that ended up being one of the least important product specifications for the project. So these sort of formed a guideline of how we're going to develop the product as we move on.
So as for economic analysis, we are given a fixed cost for a year for $11,250, and we decided that our production cost to be $60, and we are going to sell it for the retailers for $120. And after that, we estimate that the retailers might increase the price before selling to the public by around approximately $79.99, and that leads to the real market price, which is the price that our customers will get, is $199.99. That may seem a little bit high compared to those competitive products, but I think the price tag just under $20 is still appealing to most of our considered customers. So as you can see in the graph, we need to sell 188 products to break even our total cost. So our team decided to manufacture 400 units per month. That is 4,800 units per year. And at the most products sold, we reach our maximum profit, which is around $276,000.
Over the course of this presentation, we have discussed several different topics. First, we discussed why we chose Proposal 3. That was because it showed the most profitability in the future and now, despite some of its challenges. We discussed how we took the customer interviews and we changed those into real criteria that we could use to judge our future product ideas. We also discussed specifications and how those specifications related to our customer needs. And finally, we discussed how the economic analysis shows that this is a viable and profitable product for VTEPs to pursue. We are Design Team 1, representing Motioneering from VTEPs. We thank you for listening to our Design Phase 1 presentation.
Thank you.
Thank you.